Hello friends, good afternoon. In the last class, we studied about refraction through the spherical surface. We know that there are two types of spherical surface. One is known as a convex spherical surface, another one is known as a concave spherical surface. Then we studied the refraction through the spherical surface, that is a convex as well as a concave. Then the next part of a refraction is refraction through the prism. In the first part, we study about refraction through the plane surface. Second part, refraction through the spherical surface. And the third part of this ray optics is a refraction through the prism. We know that the prism is an optical medium. We know that optical medium is a that which allows to propagate the light through it. Is known as an optical medium. So prism is also a optical medium which allows to propagate light through it. So is known as a prism. So here prism, what is the meaning of prism? Prism is an optical medium. Prism is a optical medium. Is a optical medium. Optical medium which is bonded. Which is bonded. Which is bonded by two triangular and three rectangular surface and three rectangular surface. So see, prism is a optical medium which is bonded by two triangular and three rectangular surface. That is known as a prism. So in the prism, there are three surfaces are there. Out of the three surfaces, the two surfaces are refracting and the one surface is known as a base. Then see what type of prism is there. So prism is a optical medium which is bonded by two triangular and three rectangular surface. So here prism, how to draw the prism? In this there are three rectangular and two triangular surface. So here how to draw the prism? So here, this is known as a prism. In the prism, there are three rectangular surfaces. So here, A, B, A, B, C and D. A, B, C and D. This is the first rectangular surface. Second one is A, B, E and F. So this is a second rectangular surface, and the third one is a C, D, F, G. C, D, F, G. So in this type, there are the three rectangular surfaces are in prism. So here, first one rectangular is A, B, C and D, and A, B, E, F, A, B, E, F. And the third one is a C, D, F, E. C, D, F, E. So these are the three rectangular surface in the prism. Rectangular surface in prism. And there are two triangular surfaces. These two triangular surfaces are CBE, CBE, and another one triangular surface, that is a here DAF, DAF. So these are the two triangular surfaces. So in this type, this is a figure which is related for the prism. So we know that prism is an optical medium which is bonded by two triangular and three rectangular surfaces. So in this type, there are three rectangular surfaces are there in the prism and the two triangular surfaces are in the prism. So here, what happened when the ray of a light is incident on the prism, it is split up into the number of colors. Means when the ray of light is incident in the prism, that is split up into the number of colors. So we know that there are two types of a light. When the light is propagated from one place to other place, there are two types are there. One is known as a monochromatic light and the other one is known as a composite light. There are two parts of a light. So in the light, mainly there are two parts are there. One is a monochromatic, another one is a composite. So here, what is the meaning of monochromatic and what is the meaning of composite? When the ray of light is propagated from one place to other place, there are two forms of a light. One light is known as a composite light, and the second one is known as a monochromatic light. Monochromatic light. So here, when the light is propagated from one place to other place, it propagates in the two forms. One is known as a composite light and another one is known as a monochromatic light. Monochromatic light is that which consists of a single color, which consists of a single wavelength. Means monochromatic light is that which consists of single color, such as the red, green, violet. There is only one color is there. But the composite light is that which consists of a several colors, which consist of several colors. So see in this type, when the light is propagated from one place to other place in the two forms. One is known as a monochromatic or that is known as a composite. That monochromatic light is that which consists of a single color, and a composite light is that which consists of a several colors, means which consists of a number of colors. For example, when the ray of light is propagated from the sun, means from the sun, the light rays those are coming on the earth's surface, those are known as a composite light. Means that sun rays are consist of a 7 colors. Those are red, violet, green. In this type, those are separate colors are there. But in the air medium, we have got only one color, that is a white color. But when that ray, because the speed of a light in an air medium is the same. The speed of light in air medium is the same. For each color, the speed of light is the same in the air medium. Because of that, we got the ultraviolet rays are in the white color. But when those light rays are incident on the other surface, when those light rays are incident on the other surface or on the other medium, means for example, air medium to water medium, air medium to glass medium, means when those light rays are incident on the other surface, that time those are separated. Means that composite light is split up into the several colors, because the velocity of a light for each color is different in other medium. Velocity of each color has a different. Red has a different velocity, violet has a different velocity. Means depending upon that, when the composite light ray is incident on the other medium, it is split up into the number of colors. So when those are split up into the number of colors, due to its change in velocity or due to its change in wavelength. But we know that the frequency of light is the same in each medium. So in this type of this prism is used to split up the number of colors. Means when the composite ray of a light is incident on the prism, it is split up into the several colors, and that is known as the dispersion of a light. When the composite light is incident on the prism and inside the prism, the ray of light is refracted, and that refracted ray is split up into the number of colors. So in this type, the use of a prism is find out to dispersion, because in the dispersion means there are several colors, those are separated depending upon their velocity. So this prism is used. So in the prism, mainly there are three rectangular surfaces. Out of three rectangular surfaces, two surfaces are refracting surface. Two surfaces are well polished. So here this surface and this surface is a well polished, and the base is a rough. Means there are two refracting surface in the prism and one surface is a rough, and that is known as a base. Means when the ray of light is incident on the first refracting surface, it is refracted and again it is coming out from the other surface. So inside the prism we have got the number of colors. So this is a prism. Then in this class we derive the expression for the refractive index of a prism. We can find out on which factor the refractive index of a light is of a prism is depend, or what is the related formula for the refractive index for the prism. Derive the expression. Derive the expression. Derive the expression. Derive the expression for refractive index for prism. For prism. Derive the expression for refractive index for the prism. Or this is a very important question for the annual examination, that is a 5 marks. Every year repeated question. Derive the expression for the refractive index for the prism, or derive n is equal to sin a plus b divided by 2, all divided by sin a by 2. So in this type this question is there. Derive the expression for the refractive index for the prism. So to derive this expression, we consider a principal section of a prism. Consider a principal section of a prism. So here how to draw a figure which is related for the refractive index of a prism. So consider a principal section of a prism. So here how to draw the figure on how the refraction is that takes place inside the prism. If we consider the principal section of a prism, so we know that prism, in the prism there are three sides are there. Out of the three sides, two sides are refracting surface and the one side is a base. Suppose if we consider the prism, this is known as a principal section of a prism with the refractive index m. Consider a prism. So these are two refracting surface, that is A, B and AC, where BC is the base. Consider a principal section of a prism. In the prism, there are three sides are there. Out of the three sides, two sides are refracting, that is AB and AC are the two refracting surface. So here, how the refraction is takes place when the ray of light is incident on this. Means when the ray of light is incident from the rarer medium to the denser medium. Suppose the prism whose refractive index is a n2 because this is a denser and which is a placed in other medium whose refractive index is a n1. Consider a principal section of a prism ABC which consists of a two refracting surface AB and AC and BC is a base. The refractive index of a prism is a n2 and which is a placed in a air medium that is a n1. If the ray of light is an incident on the prism on the first surface, if the ray of light is an incident on the first surface AB, suppose PQ be the ray of light, PQ be the ray of light, PQ be the ray of light which is an incident from air medium to the denser medium, or when the ray of light is an incident on the first refracting surface AB, this ray of light is propagated from air medium to the denser medium. So draw a normal ray at a point of incidence. So draw a normal ray at the point of incidence. M. So draw a normal ray at the point of incidence. So here M be the normal ray to the surface AB. PQ be the incident ray. M be the normal ray which is drawn at the point of an incident. This ray of light is propagated from rarer medium to the denser medium. The ray of light is propagated from rarer medium to the denser medium. And we know that when the ray of light is propagated from rarer to denser, it bends towards the normal. It bends towards the normal, and in the homogeneous medium, the ray of light is propagated in the straight line. So here, this prism is a homogeneous medium with a refractive index n2. The ray of light is entered from the air medium to the denser medium, so it is a bend towards the normal. It is a bend towards the normal and it is propagated in the straight line direction. So here, show the arrow mark. PQ be the incident ray, MN be the normal ray, then the angle which is a find out in between the incident ray and the normal ray is known as the angle of incidence, and for the first surface the angle of incidence is I1. If we consider for the first surface angle of incidence is I1. Then here suppose QR be the refracted ray for the first surface AB. QR be the refracted ray for the first surface AB. Then the angle which is a find out in between the normal ray and the refracted ray is known as the angle of refraction, that is R1. Label the diagram. PQ be the incident ray. The angle which is find out in between the normal ray and the incident ray is known as the angle of incidence. QR be the refracted ray for the first surface AB, and the angle which is find out in between the normal ray and the refracted ray is known as the angle of refraction, and this angle of refraction is for the first surface, that is R1. Let's see the second surface AC, where AB and AC both are the refracting surface. So QR be the ray of light which is refracted from the first surface. QR be the ray of light which is refracted from the first surface, and QR be the ray of light which is incident on the second surface. QR be the incident ray for the second surface, and QR be the refracted ray for the first surface. Then here, when the ray of light is incident on this, at the point of incidence, we draw in normal line. So here, this is a normal line which is at the point of incidence. Suppose this is a MM, suppose this is a TM. So TL be the normal line to the second surface. Then the angle which is find out in between. So this is the R1 refracted angle. Suppose this is the incident angle for the second surface. So if we give the name for this is the R2. The angle which is find out in between the normal ray and the incident ray, that angle is known as the angle of incidence, and if we consider that angle of incidence is R2. Then when the ray of light is propagated from this is the incident ray for the second surface. Again the ray of light is propagated from denser medium to the rarer medium, and we know that when the ray of light is propagated from denser to rarer medium, it bend away from the normal. It bends away from the normal. So here this ray of light is bends away from the normal. So P, Q, R, and suppose this is a S. So RS is known as a immersion ray. RS is known as a immersion ray. Then the angle which is find out in between the normal ray and the immersion ray, that angle is known as the angle of the immersion, otherwise that is a refracted angle. Then if this emergent angle is considered with the letter I2. So in this slide we label the figure. When we label this figure, we draw a ray diagram correctly. We consider a principal section of a prism. We consider a principal section A, B, C in the prism. When we consider the principal section A, B, C, in this AB and AC are the refracting surface MN normal to the first surface, AB, and first surface angle of incidence is I1, and angle of refraction is R1. Where P to be the incident ray, we draw a normal, and the angle which is find out is known as the angle of incidence. Q1 to the refracted ray for the first surface, and the angle is known as the angle of refraction, and this ray is incident on the second surface, and that time the angle of incidence is R2, and the ray is refracted away from the normal, and that is known as the angle of immersion I2. So in this slide, for the second surface, angle of incidence is I2, and angle of immersion is I2. Then here your aim is to derive the refractive index of prism, and we know that refractive index for prism, or the related formula for the refractive index according to the Snell's law, is N2 by N1 is equal to sin I by sin R. Means your aim to find out the sin I by sin R. So here how to derive the expression. So see the figure. If the prism is not there, or if the medium is the same, the ray of light is propagated in the straight line direction. Means if the prism is not there, the ray of light is propagated in the straight line direction. So see here, This ray is known as a incident ray. Incident ray. If the prism is not there, the ray of light is propagated in the same direction. But due to the prism, due to the change in medium, the ray of light is emergent from here. Means the change in angle is known as the angle of a deviation. The angle which is find out in between the incident ray and the emergent ray is known as the angle of deviation. So to find out the angle of deviation, so here if the prism is not there, the ray of light is propagated in the same direction. But due to the prism, the ray of light is propagated from here. So the change deviation is the angle which is find out in between the incident ray and the emergent ray is known as the angle of deviation. So here this is the incident ray, this is the emergent ray, draw a perpendicular from the emergent ray, and this is known as the angle of deviation delta. So this is known as the angle of deviation. So we know that angle of deviation is that the angle which is find out in between the incident ray and the emergent ray, that angle is known as the angle of deviation. Let's here find out the angle of deviation. Find out the angle of deviation. So here how to find out the angle of deviation? First find the angle of deviation. Find the angle of deviation. This is the first part of this derivation. Find the angle of deviation. Let's see the figure. In this, angle of deviation is the angle which is find out in between the incident ray and emergent ray is known as the angle of deviation. They say how to find out this. So see the figure. AQNR. This is known as a quadrilateral. We draw a perpendicular from here. Suppose this perpendicular is Z. We draw archer with the perpendicular on this line. Then see the triangle QZR. See the triangle QZR. So in this triangle, this angle delta is the exterior angle. This angle is an exterior angle for the triangle ZQR. So your aim is to find out the angle of deviation. So see the figure, angle of deviation is the exterior angle for the triangle ZQR. So here the exterior angle is the sum of an interior angle. Exterior angle is the sum of an interior angle. Then here this is the I1, this is known as the R1. Then the angle which is the find out in between the incident angle and the refracted angle is known as the angle of deviation delta, and suppose if we consider by delta 1. In the last period we study about that the angle which is find out in between the incident angle and the refracted angle is known as the angle of deviation. So this is the delta 1. And here this is the emergent angle and this is the incident angle, and this is the refracted angle, this is the incident angle, and the angle which is find out in between the incident angle and the refracted angle is known as the angle of deviation. So this is the delta 2. So see the figure, delta is the exterior angle for the delta 1 and delta 2. So here see the figure, this is the exterior angle for the triangle ZQR. So to find out the deviation delta is the exterior angle and exterior angle is the sum of an interior angle. So here how to find out delta? Delta is equal to sum of an interior angle. So consider a triangle. So to derive the expression for the angle of deviation, consider a triangle QZR. Consider a triangle QZR. In the QZR, delta is the exterior angle and delta 1 and delta 2 are the interior angle. Therefore, delta is equal to delta 1 plus delta 2. Delta 1 is the deviation due to the first surface and delta 2 is the deviation due to the second surface. So to find out the deviation due to the prism, that is the exterior angle. Exterior angle is the sum of a interior angle, that is a delta 1 plus delta 2. Then find out the value of a delta 1. So delta 1 is equal to I1 minus R1. In the last class, in the refraction, we study about deviation is the difference in between the incident angle and the refracted angle. Therefore, delta 1 is equal to I1 minus R1. I1 minus R1. And see this figure where I2 is a large and R2 is a less. Therefore, delta 2 is equal to I2 minus R2. Substitute the value of delta 1 and delta 2 in the above equation. Suppose this is the equation number 1. Substitute the value of delta 1 and delta 2 in the above equation. That is delta is equal to I1 minus R1 plus I2 minus R2. So simplify this. Delta is equal to I1 plus I2 minus R1 plus R2. So here, this is our important formula to solve the numericals. First one is a delta is equal to delta 1 plus delta 2. Then second, delta is equal to delta 1 plus delta 2. And here, delta 1 is equal to I1 minus R1 plus delta 2 is equal to I2 minus R2. So we substitute here. So suppose this is the equation number 2. Then to find out the value of a refraction or to find out the other values, we consider a quadrilateral. And that quadrilateral is AQNR. Consider a quadrilateral. AQNR. So in the quadrilateral, we know that there are 4 angles are there. The first one angle is A, and where A is known as the angle of a prism. Angle of prism is that the angle which is found out in between the two refracting surface is known as the angle of a prism. In the equilateral triangle, the angle of prism is a 60 degree. So here, A, B, C be the principal section of a prism and A be the angle of prism. Then in the quadrilateral, mainly there are 4 angles are there. Those are angle A, angle N, angle Q and angle R. So out of 4 angles, 2 angles are known. Because MN be the normal rate for the surface AB. MN be the normal rate. Normal rate means we know that make the angle 90 degree. And here Tn be the normal rate for the second surface. Means this also makes a 90 degree angle to the second surface. Means here angle Q and angle R are known, and those angles are 90 and 90. Means the sum of the two angles is equal to 180 degree. Means these 2 angles are known, and we know that the sum of the 4 angles in the quadrilateral is equal to 360 degree. Means 2 angles are known, then the remaining angles are 180. Therefore, in the quadrilateral, the 2 angles are known because MN and Tn are the normal rate, and those angles are 90 and 90. So consider the other 2 angles, that is the angle A plus angle N is equal to 180 degree. Suppose the equation number 3. Consider the other 2 sides, that is the angle A and angle N. Because due to the normal rays, these angles are considered to be 90 degree. Because these are known as a normal rays. Normal rays are perpendicular to that surface. Perpendicular means which makes the 90 degree. So in this typo, where angle A and angle N is equal to 180 degree. Then again consider a triangle QNR. Consider a triangle QNR. Consider a triangle QNR. And in the triangle QNR, there are three angles are there, and the sum of the three angle is equal to 180 degree. So consider the another one triangle, that is a QRN. In the triangle, there are three angles are there, and we know that the sum of the three angle is equal to 180 degree. So see here how many angles are there. The first one is a R1, second is a R2, and third is a angle L. So first angle is a R1, second angle is a R2, plus third angle is a angle L is equal to 180 degree. So this is equation number 4. Consider a triangle QRN. In that triangle, mainly there are three angles are there, and the sum of three angle is equal to 180 degree. And those angles are R1, R2, and angle L. Therefore, the sum of the three angle is equal to 180. R1 plus R2 plus angle L is equal to 180. Then compare the equation 3 and 4. Compare the equation 3 and 4. So when we compare the equation 3 and 4, this one side is the same. That angle N same. Means this value is also same. That is the angle A is equal to R1 plus R2. Equation number 5 is a very important equation to solve the numericals. That is the angle A is equal to R1 plus R2. Means by comparing these two, when we consider a triangle QNR, in this triangle, mainly there are three angles are there, and the sum of three angle is equal to 180 degree. And those three angles are angle R1 plus angle R2 plus angle N is equal to 180 degree. Then we compare the equation 3 and 4. When we compare the equation 3 and 4, this side is the same, this N is same, means angle A is equal to R1 plus R2. So we got the value of a angle A. Angle A is equal to R1 plus R2. So substitute the value of angle A in the equation number 2. Substitute the value of a angle A in equation number 2. So see the equation, delta is equal to I1 plus I2 minus A. So this is also a very important formula to solve the numericals. That is the delta is equal to I1 plus I2, where R1 plus R2 is equal to angle A according to that equation number 5. Therefore, delta is equal to I1 plus I2 minus A. Otherwise, I1 plus I2 is equal to delta plus A. So see the equation number 6. So here, we can derive the value of a delta, as well as we can derive the value of an angle A, where angle A is the angle which is found out in between the two refracting surface, and that is known as the angle of a prism. So in this type we find out these values. Let's see how to derive this equation or how the emergent angle changes. So here see the figure. If the incident angle changes, when the incident angle changes, the refracted angle changes. And when the refracted angle changes, the angle of emergent is also changes. When the incident angle changes, because according to the Snell's law, sin I is directly proportional to the sin I. Means I is directly proportional to R. When the angle of incidence changes, angle of refraction is also changes. So depending upon this, if the angle of incidence changes, the angle of refracted is decreases. But for a particular angle, the angle of refraction and angle of incidence both are same. Means the angle of incidence and the angle of emergent both are same, and that is known as the angle of the minimum deviation. That is known as the angle of minimum deviation. Angle of minimum deviation is that in which the angle of incidence and angle of emergent both are same. So here, when the angle of incidence changes, if we draw the graph which is related for the angle of incidence and angle of emergent I1 and I2, and if we see the deviation, if the incident changes, refracted it also changes, and if refracted it changes, angle of emergent it changes. Means I1 is depends upon I2. When I2 is increases, that I1 is increases, I2 is decreases. But when it is decreases, when it goes on increasing, when the value of I1 is goes on increasing, starting the I2 value is decreases, but again it is decreases. And we have got the graph which is related for this. So this is known as the graph which is related in between the angle of incidence and the angle of a emergent. So here for a particular angle, suppose if we consider here deviation, and if we here consider the deviation, where the I1 and I2 both are same. I1, I2 are both are same, and that is known as a minimum deviation. That is known as a minimum deviation. So this value is a D1, this value is a D2. But for a particular value, angle of incidence and angle of emergence both are same, and that position is known as the angle of minimum deviation of a position. So here, what is the meaning of angle of minimum deviation here? Angle of minimum deviation is that where the angle of incidence and angle of emergence both are same, and that position is known as the minimum deviation position. So here, if the prism is set in the minimum deviation position, so that position is denoted by the letter capital D. So when the prism is in the minimum deviation position, so that time when the prism is set in the minimum deviation position, when the prism is in a minimum deviation position, prism is in minimum deviation. Minimum deviation is a that in which the I1 is equal to I2 or the angle of incidence is equal to angle of emergence. That position is known as a minimum deviation position. For this case, I1 is equal to I2. Means I1 is equal to I2 and the R1 is equal to R2. So these values are same. Means that time the prism is set in the minimum deviation position. So if we consider the prism is in the minimum deviation, that time the values are I1 is equal to I2 and R1 is equal to R2. Then here what happened? When the prism is in the minimum deviation, we write this by the capital D, that is a D minimum deviation. I1 is equal to I2 means when the I1 is equal to I2, I1 is equal to I2 means this is equal to I plus I. I plus I is equal to 2I. 2I minus A. Here we want to find out the value of a I. Therefore 2I is equal to D plus A. Therefore I is equal to A plus D divided by 2. So here we have got the value of a I. I is equal to A plus D by 2. What is the meaning of I here? Angle of incidence. I is equal to A plus D by 2. We got the value of a I. This here, in this formula, we find out A is equal to R1 plus R2. But when the prism is in a minimum deviation position, R1 is equal to R2 is equal to R. So R1 is equal to R2 is equal to R. So when R1 is equal to R2 is equal to R, then A is equal to R plus R is equal to 2R. Therefore, R is equal to A divided by 2. So we got the value, both the values I as well as R. When we find out the value of I and R, then your aim is to derive the expression for the refractive index of a prism. And according to the Snell's law, the refractive index of a prism N is equal to sin I by sin R. N is equal to sin I divided by sin R, where N2 divided by N1. So N1 is air medium. N1, the prism is a set in the air medium, means the refractive index for the air medium is a 1. Therefore, N1 is equal to 1. And N2 is a glass medium, that is considered to be N. Therefore, N is equal to sin into I. We derive the formula which is related for the I. Sin A plus D divided by 2. Sin A plus D we divided by 2. And divided by sin R, where sin R is equal to A divided by 2. So in this type we derive the expression which is a very important expression, that is a refractive index for the prism. So in this type we derive the expression for the refractive index for the prism. So here to derive this expression we consider a principal section of a prism. In this principal section of a prism that is ABC, be the principal section of a prism. In this, PQ with a ray of light, which is an incident on the first surface, draw a normal line at the point of incidence, and this angle is known as the angle of incidence I1. When the ray of light is incident on the first surface, it is a refracted from the air medium to the denser medium. And when the ray of light is refracted from air to denser, it is a bend towards the normal. So the angle which is find out in between the incident ray and normal ray is known as the angle of incidence, and this is known as the angle of a refraction. So again, this ray of light is incident on the second surface, where the angle of incidence is R2, and the ray of light is emergent out, and the angle which is find out in between the normal ray and the emergent ray is known as the angle of a emergent, that is I2. Then, to find out the angle of deviation is that the angle which is find out in between the incident ray and the emergent ray, that angle is known as the angle of deviation. So this is a emergent ray, this is the incident ray. So draw a perpendicular or draw a straight line from the emergent ray, and where the both rays are meet, that is known as the angle of deviation. So to find out the angle of deviation, consider the triangle ZQR. So in this triangle ZQR, where this angle is the exterior angle, that is a delta. Exterior angle is the sum of an interior angle, that is a delta is equal to delta 1 plus delta 2. So here delta is equal to delta 1 plus delta 2. Let's say delta 1. Delta 1 is the deviation due to the first surface AB. That is delta 1 is equal to I1 minus R1. I1 minus R1. And delta 2. Delta 2 is the deviation due to the second surface. Delta 2 is equal to I2 minus R2. So we substitute the values in the first equation. That is delta is equal to I1 minus R1 plus I2 minus R2. Therefore delta is equal to I1 plus I2 minus R1 plus R2. So we derive this expression, or we consider a quadrilateral. We consider a quadrilateral, that is AQNR. In this quadrilateral, this MN and TN both are the normal rays. Normal ray means which makes the 90-degree angle. Means both these angles are 90-90. And we know that the sum of the four angles is equal to 360. Out of the four angles, if the two angles are 180, means the remaining angles are also 180. So we consider the angle A plus angle N is equal to 180. Angle A plus angle N is equal to 180. Again we consider a triangle QRN. In this triangle, there are three angles are there. One is angle R1, angle R2, and this is an angle N. And the sum of the three angles in the triangle is equal to 180 degree. So this is a R1 plus R2 plus angle N is equal to 180. We compare equation 3 and 4. When we compare the equation 3 and 4, 180 same, angle N same. Therefore, angle A is equal to R1 plus R2. So see here, after this, when the prism is set in a minimum deviation position, when the prism is set in a minimum deviation position, and the minimum deviation position is that in which the incident angle and the emergent angle both are same. When the incident angle and emergent angle both are same, that position is known as a prism is set in the minimum deviation, because the angle of emergent is a totally depends upon angle of incidence. When the incident angle is goes on increasing, initially the angle of emergent is decreases, but after then when we again increases the incident angle of emergent is again increases. Means emergent angle is initially decreases and it is again increases. Means for a particular time the I1 is equal to I2 and the R1 is equal to R2. Therefore we substitute the, or when the prism is set in the minimum deviation position. Or we also say that when the refracted ray QR is parallel to the base, that time the prism is set in the minimum deviation position. So that time R1 is equal to R2 and I1 is equal to I2. And the prism is a minimum deviation position. So that is denoted by the letter delta D. D is a minimum deviation position. And minimum deviation position is that where the angle of incidence and the angle of emergence both are same, and angle of incidence and the angle of refractive both are same. That is I1 is equal to I2 and R1 is equal to R2. So in this type we consider I1 is equal to I2 is equal to I. Therefore I plus I is equal to 2I. Therefore delta minimum 2I minus A. Therefore I is equal to A plus B by 2. Here, A is equal to R1 plus R2. Therefore, A is equal to R plus R is equal to 2R. Therefore, R is equal to A by 2. Then your aim is to find out the value of a refractive index of a prism. Then according to the Snell's law, refractive index of a prism is equal to N2 by N1 is equal to sin A by sin 1. Sin I is equal to A plus D by 2. A plus D by 2 divided by sin R. Sin R is equal to A by 2. So in this type, we derive the expression for the refractive index for the prism. That is a very important formula. Where A is the angle of prism, D is the deviation, and A is the angle of prism. So in this type, we derive the expression for the refractive index for the prism. Then we derive the expression for the refractive index for the thin prism. Thin prism is a that whose angle of prism is a very small. Thin prism is a that whose angle of prism is a very small. That prism is known as a thin prism. Deviation due to the thin prism. Deviation due to thin prism. Thin prism is a that whose angle of prism is a very small. Whose angle of prism is a very small, that is a less than 10 degree. Is known as a thin prism. So to derive the expression for the thin prism, we consider a prism. We consider a principal section of a prism. So here, in this principal section of a prism, when the ray of light is incident on the first surface, this is known as the angle of incidence, that is the I1. When the ray of light is refracted, this is the refracted angle R1. Suppose this is the second surface. And the ray of light is refracted. If this is the incident angle is the R2 and this is the emergent angle is the I2. To find out the refractive to the thin prism, we apply the Snell's law for the first surface. We know that the Snell's law is N2 by N1 is equal to sin I divided by sin R. Sin I by sin R. So N1 is a air medium. Therefore N is equal to, if this is a very thin prism and the angle is very small, so we consider I sin I is nearly equal to I. And for the first surface, N sin I1 means that is the incident angle is the I1 and the refractive angle is the R1. Therefore, I1 is equal to N into R1. Suppose this is the equation number 1. Then say apply this formula for the second surface. That is for the second surface, N2 by N1 is equal to sin of a I2 divided by sin of a R1, R2. Therefore, N is equal to, if this prism is a very small, very thin, Therefore, n is sin I2 is nearly equal to I2. Sin R2 is nearly equal to R2. Therefore, n is equal to I2 by R2. I2 is equal to n into R2. So when we substitute this value in the first equation, we just find out in the first derivation, that is a deviation is equal to I1 plus I2 minus R1 plus R2. So here D is equal to R1 plus R2 is equal to A. I1 plus I2 is a n R1 plus n R2 minus A. Therefore, if we take n common, D is equal to n into R1 plus R2 minus A. Where R1 plus R2 is equal to A. Therefore, D is equal to n into A minus A. Therefore, D is equal to, if we take A common, n minus 1. So, this is known as the deviation due to the thin prism. Thin prism is that whose refractive index or whose angle of prism is a very small, that is a less than 10 degree. So, here, this formula is a very important for the numericals. So, when we derive the expression for the deviation due to the thin prism, we consider a prism when the angle of incidence is I1, angle of refractive is R1. Therefore, to find out the refraction through the first surface, n2 by n1 is equal to sin I by sin R, where n is a air medium. Therefore, n is equal to I1 by R1. Therefore, I1 is equal to n R1. D is equal to I1 plus I2 minus R1 plus R2. Same formula which is related for the second surface, that is n is equal to I2 by R2. I2 is equal to n R2. Therefore, D is equal to n into R1 plus R2 minus A. Where R1 plus R2 means A. That is a D is equal to n into A minus A. If we take A common, deviation due to a thin prism is a D is equal to A into n minus 1. So in this type, we derive the expression for the deviation due to the thin prism.